Continuing on our example and basic walkthrough of drainage and utility nodes and the SUDA cells that are referenced into the drainage and utility feature definitions. Typically you'll create your 2D cell and then afterwards you'll create your first 3D cell, which for a catch basin or inlet is the top cell, and for an end section or end wall would be a bottom cell. Similar to the 2D cell, you're going to have three reference elements that the drainage and utility model is going to use to connect these cells together and within the 3D model. If I open up my element properties using Control I can see I have 2 points and a line. The first point that's highlighted is a magenta colored point, and this is the elevation point reference. This point informs the feature definition where the elevation for the top is supposed to be placed. This can be used in conjunction with a top surface or terrain typically, and this is where the rim elevation in the hydraulic model will be placed. It's important to know the line style for this is 5 and the class is construction. Just like in the 2D cell and other cells, make sure the correct amount of pseudo elements are in here, not duplicated or not less than the 3 that are required as mentioned before. Moving on to the second SUDA element to review. This is called the alignment line, and just like in the 2D cell, this controls the rotation of the cell, and this should correspond to the one in the 2D cell as well. You can notice that I have the elevation point higher than the alignment point and alignment line. And lastly, we have the alignment point, and this is used to connect the bottom cell if a bottom cell is used, as well as connect to the 2D plan view cell. I won't be going into depth on how the solids or the surfaces are created, but the easiest place to do this is in modeling, and you have options here such as slabs, spheres, cylinders, and solid by profile. A lot of cases, if I want to draw a box solid, I'll create a rectangle and solid by profile, giving it a depth, and you can see I've created another solid here, and I can orient it wherever it needs to be. One thing to notice is this is a parametric solid and this is a smart solid. For whatever reason, it doesn't seem to display parametric solids very correctly in the feature definition. So in every case, when you've created a parametric solid or another surface, you want to convert it to a smart solid or a smart surface. And that can be done by going to the ribbon and either convert to solid, and you'll highlight the solid, change it to smart solid, and you can see that this is a smart solid now. Or if it is a primitive surface, you'll need to convert that to a smart surface as well. And that's done similarly by highlighting the primitive surface and putting in the ribbon, convert to surface, changing it to smart surface, and then clicking. As I've previously stated, this serves as the top cell for the 3D model if it is a catch basin or manhole. If it's an end section or a head wall, the construction's the same. However, it will be treated as a bottom cell. And I can pull up a 30-inch concrete end section. And you can see it's materially the same. It has all the relevant SUDA elements, with the exception that it has one more elevation point in case it's placed on the top instead of the invert.